Hey Isaiah, I wanted to show you how to open your Greenfoot project, the War card game, in Coding Room. So I sent you a link. Once you click on that link, it's probably going to prompt you to sign in to Coding Rooms. But eventually you should get something like this, where over on the left-hand side are all the files. The only one you need to edit is myworld.java. Okay, so that has your code, the methods, the comments on how you're supposed to write uh, uh, the methods that you need to finish the lab. If you want to run it, okay, which I encourage you to do, you click down in the lower right hand corner and then click View Desktop. So you'll click on that, it'll connect. You'll see a little thing of Greenfoot, and then what I recommend is you maximize the screen. So this little slide out tab here, you click on the full screen button. That will bring up Greenfoot into full screen mode. It'll look similar to in class. In fact, if you click this plus button, it will maximize it and it will look exactly like it does if you're running on a computer. Now, there's one final step to get your lab or project to open. You have to go to Scenario Open. It will automatically take you to the folder that has all of your files, and all you need to do at that point is click Open. Okay, and now it has your full project, and you should be able to instantiate a world. I think it might do it itself, but if it doesn't, you want to right click on it and do, well, it may take it a while to compile. But then you can actually, if you want, you can actually edit your code there as well. So, in fact, you might want to try editing your code from within the virtual Greenfoot. And yeah, so it looks like in looking at your project, it looks like you've distributed the cards, and then it looks like you almost have move cards forward. So move cards forward, basically you're just reassigning every I+1 element to the I element beginning at 1. So it looks like you almost have that done. And then in the shoot method, I'm going to start it for you. The first thing is you're going to check to see if player 1 and player 2 have enough cards. So number of cards player 1 keeps track of the end of player 1's deck. So what you do is you say, okay, if and each of them need at least one card to play for the shoot to work. So you say if num cards greater than 0 and num cards player 2 greater than 0. Now make sure, let me make sure you assigned the values. Okay, you did. You have to start assigning the values 26 and say game state equals running. So if one of those things is not true, you need to say game state equals finished. Okay, then there's 3 other scenarios that you need to handle. One would be that player 1 deck, wait, is that what they're called? No, player 1 deck, yeah, good. Is greater than dot get card. Now, player deck 1, because we're comparing the playing card objects in the 1 position, dot get card value, that gets its card value, is greater than player 2 deck 1 dot get card value. Okay, so that means player 1 has won. shoot. So you have to take each player's number one card and assign it to the end of player one's deck. So you're going to make assignments to the num cards plus one and num cards player one plus one and the num cards player one plus two elements of the player one deck. And then after you do that, you need to call the move cards forward method, and you need to increase num cards player one by one and decrease num cards player two by one. Okay, so then pretty obviously, the next scenario is that player two wins. Okay, so it would look like that. Okay, so obviously you're going to do the same thing except making assignments to the end of player two's deck, moving all the cards forward for both players. So you call it twice, once for the one guy and once for the other guy, I think. Let's see, or no, does it do it? No, move cards forward needs to do it for both. So you only call it once. And then the final situation would be the war situation. So there's only four possible outcomes of them drawing. Either they can't draw because one doesn't have enough cards. They can draw, one of them wins, is because their card's greater than the other. Okay, so there's two possibilities there. Or the final thing is it's war. Okay, because their card values are the same. So in the war situation, you are going to do a comparison of, well, oh no, I'm sorry. First, you need to make sure each of them, you need to check to see if each of them have at least four cards. Because if they don't, the game ends and the player who obviously didn't have enough cards loses and the other guy wins. Which you don't, all you need to do is say game state equals finished. The ACT method will take care of identifying who has won. So you would say if num cards player 1 less than 4 or num cards player 2 less than 4. Okay, you're going to do game state equals, oops, I did a typo here. You're going to say game state equals finished. Oops, if I can spell game state. Okay, so that's one outcome, and there are three more outcomes. The one guy wins the war, the other guy wins the war, or it has to go to double war. Okay, so you're going to have an else if I can spell else if. There's a lot of lag here because I'm recording this and we're running Greenfoot in the cloud. So now you are going to compare the fourth card. Okay, so you say player 1 deck 4 dot get card value greater than player 2 deck 4 dot get card value. Okay, so that's the one guy. Player 1 wins the war. Okay, and then obviously you're going to have the other guy winning the war is going to be your next possibility. So you would do else if, and then really you can just copy and paste all of that and change the 1s to 2s. So okay, so I'm just going to say change that to a 2 and this to a 1. Okay, so that's the second outcome. Now, in both those cases, you're going to have to make 8 assignments to the end of the winner's deck, right? The winner is going to get his own cards that are in positions 1, 2, 3, and 4 of his array of playing cards, and he's going to get the other guy's first 4 cards. So all 8 of those cards need to be put at the end of the winner's deck, and of course you would be assigning them to position number of cards +1, num cards +2, +3, +4, +5, +6, +7, and +8. Now you can write a loop to do that, a for loop to do that, or you can just have 8 assignment statements. I'm not really fussy about that. But after you do that, remember, you will have to move the cards forward 4 times now. And you'll have to increase the number of cards in the winner's deck by 4. So you'll increase that num cards player whatever by 4. Okay, so then, oops, and I shouldn't have a semicolon there. Okay, so then the last thing, oops, and I forgot the brackets, or they didn't type. So then the last thing is it has to go to double war because both cards were the same. Okay, and at this point you kind of repeat the process. Okay, and the whole process, right? If it goes to double war, there's 4 possibilities. This time, you're making sure that each player has at least 7, let's see, no, at least 8 cards. Okay, so so that would be the first thing. Then you're comparing the 8th card and not the 4th card. And then, so if somebody wins, you have to put 16 cards at the end of the winner's deck, right? All the cards that are in positions 1 through 8 of each player. Then you'd have to move the cards forward 16 times and increase the number of cards that the winner has by 8 and decrease the losers by 8. So that would be double war. And then else, you would have to go to triple war. Okay, and in that case, you would be comparing the 12th card with 4 possible outcomes. Now, I'm not going to make you go past triple war, so what you can do is, if triple war is a tie, so that would be the else case for triple war, just call it a draw and move each player's cards to the end of their own deck and move the cards forward 12 times. Okay, and make game state equals finished. Okay, so hopefully that'll help you work on the lab, and we hope to see you soon, and we're hoping you're healthy, and we'll be back in class soon. All right, cheers.